Good morning, good evening, good afternoon, boys and girls. So today's lesson is about routing fundamentals and administrative distance. Let's go, let's go. Let's see what we have for today. Give me just a moment because it's taking a little bit of time to reflect. Now I got it. Nice. So what do we have is a new agenda. We're talking about an introduction, routing versus switching, routing tables, types of routing, routing protocols, path selection, administrative distance, AD values, best practices, a case study, the future of routing, and a summary. So let's do it. First, we have routers forward packets between networks, and these enable communications across subnets and critical for internet working. It is essential for internet working. Now, talking about routing versus switching. Switching forward frames within LAN, routing forward packets between networks. Then just remember switching forward frames within LAN environment, then routing forward packets between networks. Switch works at a layer 2 and the the router works at layer 3. Now, there are some switches that has layer 3 capabilities where we're working along with multi-layer switches or layer 3 switches. So just for you to be informed, they have capabilities from layer 2 and layer 3, just for you to be aware about that. Also, um, the header is what allows communication between layer 2 and layer 3. So with the header, you can have that communication. Routing table basics. It is important to be aware about, and let me just share with you guys here, the destination network, the next hop IP address, the ongoing interface, and the administrative distance and metric. Let's just type an example. Let's say our destination network is 192.168.10.2, and our next hop will be mm, will be 192.168.20.2. And let's say our going interface will be serial 010 with an administrative distance of 5. So this is an example of how it will look in real life. Maybe we will take a look at more examples later on. Usually there is a mask sometimes depending on the scenario. So there will be something like this, like a mask. So sometimes it will be like this. The destination network first, then we have the mask, net mask, the next hop IP address, and the outgoing interface. And finally, we have the administrative distance or metric. So that's a little bit of the way it is configured. We will take a look at more examples later on during the course. Let's continue within this presentation. We are talking about types of routing. Static routing, it works with manual configuration, manual entries. Dynamic routing, protocols are going to exchange routes. And finally, we have default routing. It's used when there is not a specific match. Some of the pros of static routing will be simple, secure, predictable. Some of the consequences will be manual updates, and is not scalable. This one is used in small networks for specific routes. Now, let's continue moving forward with this presentation. What else do we have important here? When we're talking about dynamic routing, um, some of the pros are it automatically adapts. It is used in large scalable networks, and some of the consequences or cons will be resource usage and complexity. It can be complex. So just for you to be aware of some of the pros, cons, and the usage of dynamic routing. Let's go ahead and clear the drawings for now and continue moving forward. Default routing. It simplifies configs in small networks. Is used to reach unknown destinations, common in branch to HQ and ISP. This is basically dynamic routing. Let's go over some of the characteristics of default routing. We're talking about default routing now. It simplifies configs in small networks, is used to reach unknown destinations, and is commonly used in branch to HQ or ISPs. So that's a little bit about default routing. Next, what do we have? We're talking about the categories, routing protocols categories. We have distance vector protocol over here, link state protocol, and hybrid. What will be an example of link state? OSPF or ISIS. Which protocols can be distance vector? We have RIP or EIGRP. And finally, we have the hybrid option, which is, in this case, BGP. Okay, time for clearing the board. Distance vector protocols. One example will be hop count metric being used in RIP. Cisco proprietary dual algorithm is EIGRP. And finally, we have that they share the entire routing table periodically. That's basically distance vector protocol. Let's move on with the next one. OSPF is an example of link state protocols. Let's analyze what they actually do. When we're talking about link state protocols, it can be OSPF or ISIS. It's an open standard protocol, and ISIS is similar to OSPF. They built a whole map of the network, faster conversions. Now, if you remember about OSPF a little bit, we're talking about OSPF database. So they create a database, and that's basically what they built. They built like a map of all the network, and it is faster in order to complete convergence. Okay, let's create the drawing. Let's continue moving on. When we're talking about path selection process, the longest prefix match, the lowest administrative distance, the lowest metric. Those are some of the path selection processes. Administrative distance, trustworthiness of a route, lower AD is more preferred, is used when multiple protocols know the same route. Next. And now we have it. Cisco default AD values. The directly connected is 0. The static route is 1. EIGRP is 90. OSPF is 110. 110. RIP is 120. And when it is not usable or unknown, it is 255. There is another one for BGP, but I don't remember at this moment. Let me look it up real quick. Let me just look it up so I can share with you. There is an internal administrative distance and an external AD AD for BGP, external and internal. So I want you to know and remember that BGP has administrative distance. What do you guys think? Yes, the external BGP is known as eBGP. It has an administrative distance of 20. Now we have the internal BGP, which is IBGP, and it has an administrative distance of 200. Just for you to be aware of those. Are we missing something? We have a static route is one, eBGP, IBGP, we have OSPF. What about ISIS? It's not used so much in nowadays, but ISIS has administrative distance of 115. What about RIP? We already have it there. It's 120. If it is unknown or unreachable, it's 255. So we can say about unreachable. If it is unknown or unreachable, it is 255. So I think we're pretty much done with this lesson, or at least this part of the lesson. Let me just clear the screen so we can move forward to the next topic. Give me just a second. Hopefully I will get there. This is an example when I was talking about before. So here we have a network. We have an administrative distance of 1. It is with, in case it is a static network. Now, if we are using a routing protocol like OSPF, remember it's a distance vector protocol, we are talking about an administrative distance of 110 or 110, and the router installed the static route. That's what the router does. Let's clear this and let's move on. Now, this is an example, and I was telling you about before, is very, very similar. The only thing that I was missing before is that I didn't add IP route command. So if you guys remember, I was doing an example before. So let's just write as we were configuring a router. Let me just work on this for a moment. So the first command will be IP route, then 10.10.10.0. That will be the destination, if you guys remember. Then the mask, net mask, 255.255.0. Next hop IP address, 192.168.1.1. And then the administrative distance of 200. Now, if you guys remember, this is a way to do it. But the one that we configured before, it was a little bit different. It was something like 192 and 168.10.2 to get to the 20.20.2, and then it was having a administrative distance of, let's just say 100, and then the serial interface was 010. Now, what I want to validate is the serial before or after the administrative distance. Let's just validate that. Give me just a moment to validate that. Is this properly configured? um, for static route. I want to validate something because I want to know if the serial goes before or after. The second one, command. Let's see if there are some issues with that one. The second one, let me share with you guys, it says that it must be the destination network, the mask, the next hop, the exit, and the distance. So let me just change this and let's just validate one more time. So it looks like I almost got it perfectly here, but we were missing something. Let me just clear the drawings for a moment. Let me just clear this and copy and paste it here. Looks like hopefully at this time we will get it correctly. And this is basically the first one. Destination, next hop, and administrative distance. That's the first example. And it was telling me there were some errors or problems with the second one. So apparently it should be the network. So instead of a 2, it has to be the specific network. So it's 0. And then the administrative distance at the end after the serial interface. So it will be IP route, destination, mask, net hop, next hop, an exit interface, and administrative distance. Remember, remembering that the correct version will be actually this one. Only the host. We can use either choice. Either choice is fine, but we can use the entire network or a specific single host. So those are the ways to do it. First, we have the option with only the administrative distance and the specific IP addresses, and then the one with the serial interface. So that's what I want to share with you guys. Let's continue moving forward with this presentation. Best practices for routing design. So backing routes with floating static, use hierarchical design, summarize routes, balance static and dynamic routing. And those are some of the best practices for routing design. Great. Let's continue moving on. Next, another is the administrative distance, and we're talking about best practices when using administrative distance. Avoid conflicts between protocols, use floating static for failover, document manual AD changes, monitor route selection. So that's a little bit of what we have here. Great. Let's go ahead and clear it and let's move on. This is a case study that we have. In this example, we are working with a corporate network in HQ. In HQ or headquarters, they use OSPF internally in their network topology. Some of the branches uses a static default route to HQ, and there is a backup loading static route via ISP with the internet service provider. So this is just a case study of real life and another example of the way routing protocols are configured in a network. And also there is even a static default route configured to get to headquarters or HQ. Let's clear the drawings. Let's move on. And now the future of routing. The future of routing. When we're talking about the future of routing, we refer as what do we want to implement in the next couple of years, and we're focusing now on the integration with automation and artificial intelligence driven path selection. That is one of the first and most popular later on. We have software defined networks in a single class, all in a dashboard integrated, and finally intent based networking. So those are, we will go into those deeper later on during the course. Now, the only one that I would like to learn a little bit more is this one, intern. So let me just ask the question. What is intent-based networking. I want to clear that out. It's a modern approach to network that uses automation, artificial intelligence, and machine learning to design, configure, monitor, and secure networks based on a business intent rather than low level device configuration. So that's a little bit, it is called intent based networking or IBM, IBN as in Nancy. Okay, let's clear the drawing. Let's move on. Let's continue with the next one. And now there is a summary. We have studied today a little bit about routing enables internet working. AD decides preferred route. The best practices to complete and ensure stability and the future trends of automation and software-defined networks. With this, we are closing the chapter for today. I hope that you have learned something from this lesson. I will see you at top of success and remember, practice makes perfect. Until next lesson, take care, boys and girls. I see you around. Goodbye.